Water vapor is the most abundant greenhouse gas, but climate deniers often distort how and why it's important. Often you'll see the claim made that water vapor is responsible for 95 or more % of the greenhouse effect.
These ideas are almost certainly wrong.
The dry atmosphere, not including water vapor, is made up of about 78% nitrogen and 21% oxygen, neither of which is a greenhouse gas, and another 1% is trace gases, including carbon dioxide. But water vapor is not evenly mixed in the atmosphere and varies by temperature, latitude, and even time of day, as the cycle of day and night produces regular pulses of evaporation. Warmer air can hold more moisture than colder air, so in hot, humid regions just above the surface, water vapor can make up as much as 4% of the atmosphere. In cold polar regions near the surface, it may make up only 0.2%. The radiation wavelengths trapped by water vapor sometimes overlap with those of other gases. Clouds further complicate the matter, sometimes reflecting and sometimes trapping heat. So best estimates of the warming effect of water vapor, including clouds, are between 66 and 85%. An important factor in radiative heat transfer is at what altitude absorption and emission take place. Higher altitudes are colder, and most water vapor freezes out as rain or snow. Satellite studies show much greater concentrations of water vapor at lower altitudes than in upper layers. If we look at a cross-section of the atmosphere, we can see the troposphere, where human beings live and work, the lowest layer. Higher up is the stratosphere, and above that, even higher, thinner layers. Water vapor has most of its effect in the troposphere. CO2 is evenly mixed and maintains the same concentration from the surface to the topmost layers, the Earth's radiative heat boundary with outer space. This greatly magnifies CO2's power relative to water vapor. Over time, mankind has added to atmospheric CO2, which remains for decades or even centuries. But water vapor stays in the air only a few days and cannot increase without increasing temperature first. If it were possible to add water to the air with some giant cosmic spritzer bottle, or as sometimes happens, a volcanic eruption, without an increase in temperature, the additional water vapor would very quickly condense and drop out. That's why climate scientists say water vapor is a feedback, not a forcing. One common denier canard is the saturation issue, where it is said CO2 is not a significant greenhouse gas because water vapor saturates the long-wave spectrum and leaves no energy left for extra CO2 to absorb. This antique idea dominated climate science in the early part of the 20th century, when crude technology and lack of interest limited research in the area.
These ideas are almost certainly wrong.
With the advent of the Cold War, the U.S. military poured money into sophisticated research using new instruments and computers to investigate radiative transfer at high altitudes, helping create a new generation of heat-seeking missiles. By the early 1950s, the absorption bands were well resolved, and popular mechanics noted that the essentials of the CO2 greenhouse warming were now understood. Gilbert Plass of Johns Hopkins University was a leader in this effort, having used newly available computers and technology to show that adding more CO2 to the atmosphere did indeed soak up and radiate more heat. A more recent denialist claim has been the idea that, as the planet warms, exotic feedbacks will create more reflective cloud effects. That the Earth's atmosphere will react like a giant iris, opening and closing to preserve planetary heat balance.
These ideas are almost certainly wrong.
These theories have not held up to peer-reviewed scrutiny. In fact, more recent studies suggest that cloud feedbacks may be strongly positive, with fewer clouds over ocean areas to reflect heat, increasing incoming radiation and warming. One effect that has been predicted for decades is that increased global temperature will increase moisture in the atmosphere, and the result will be more extreme precipitation events. This prediction is being borne out in record rain and flooding events from the American Midwest to Europe and Asia. Finally, as more moisture enters the air, the greenhouse effect of the water vapor itself will increase. A much-quoted study confirmed this effect in 2008, noting, "The existence of a strong and positive water vapor feedback means that projected business-as-usual greenhouse gas emissions over the next century are virtually guaranteed to produce warming of several degrees Celsius. The only way that will not happen is if a strong, negative, and currently unknown feedback is discovered somewhere in our climate system." Climate deniers know they have long ago lost the scientific battle. They seek to delay action with wishful thinking, fuzzy logic, and deception.